So we have question number 1.10 here, and it says, what role does the molecular interaction plays in a solution of alcohol and water? So interaction between alcohol and water is this concept is related to Raoult's law, and molecular interaction plays a vital role for defining this behavior of this mixture, right? So let's see how you can answer this. So first of all, write that molecular interaction plays a significant role in solution of alcohol and water. When you see in pure water, a strong H bond exists between water-water molecules. Then second, if you see in pure alcohol, H bond also exists in that case, and exists between alcohol molecules. And in mixture also, the H bond exists between alcohol water molecules. But what is the thing is the strength, relative strength of water molecule H bonding is very high than alcohol water, and then alcohol. So alcohol is achieving a more stable hydrogen bonding, right? That's why what happened is we see a negative deviation from Raoult's law. And what is the effect of negative deviation from Raoult's law? We can see volume contraction. Like we have taken 4 liter, and after mixing alcohol and water, it is going to become 3. Let's say we have 4 liter of water and 4 liter of alcohol. So after mixing, we are going to get 7.9 liter of mixture. So ideally it has to be 8, right? But we are getting 7.9 because why? Because the volume contraction is occurring. Why? Because the molecules, the attraction force between molecules is larger in alcohol water than alcohol. That's why they are attracting each other together, and that why the bond sinkage, hydrogen bond sinkage is occurring, and that is causing decrease in overall volume, right? So volume contraction is occurring because of this, and then heat release due to a stable bond formation. So whenever a stable bond formation is going to occur, heat is released. Whenever anyone gains stability, heat got released. Okay, so that is the thing. You can write it easily in your exam if this question comes. Okay.